Today I'm going to work through the 6 problems on the review sheet on Chapter 9. Number 1, point P having coordinates 3/5, -4/5 is a point of intersection between an angle theta in standard position and the unit circle. So right there, and the unit circle. So in other words, our point is on the unit circle. So if our point P, which has 3/5, -4/5 as coordinates, is on the unit circle, that means that the x-coordinate is equal to the cosine of our angle and the y-coordinate is equal to the sine of our angle. Alright, so the sine of theta, so we want to find all 6 trigonometric values for angle theta. So the sine of theta is equal to the y-coordinate, which is -4/5. The cosine of theta is the x value, 3/5. Tangent, remember tangent is equal to sine over cosine. And if so, that would be -4/5 over 3/5, and the denominators of 5 would divide out, so we'll simply be left with -4/3. Cosecant is reciprocal of sine, so if sine is -4/5, cosecant would be -5/4. Secant is reciprocal of cosine, so if cosine is 3/5, secant is 5/3. And cotangent is reciprocal of tangent, so that would be simply -3/4. Next, number 2, point P, having coordinates -3, 2, is on the terminal side of an angle theta in standard position. Find all 6 trig values, the quadrant, and the measure of theta to the nearest degree. Express answers as reduced fractions with rational denominators. Okay, so no mention of it intersecting the unit circle or being on the unit circle. So when we're given the point -3, 2, we're going to, I'm going to use a space to the right here, we're going to plot the point, right? -3, 2, we'll plot the point, draw the triangle, and then use SOHCAHTOA. Alright, so -3, 2, -3, +2. Here's my point. Draw the right triangle. Right. So here's theta. So we're in quadrant 2. Using Pythagorean theorem, our hypotenuse, that's 4 plus 9 is 13. So our hypotenuse is the square root of 13. So I'll be referring to this triangle when I go to find the 6 trig values. Now, in relation to theta, 2 is opposite theta, the -3 is adjacent, and of course the square root of 13 is the hypotenuse. Alright, so each time referring back to this. The sine of theta. The sine of theta is going to be opposite over hypotenuse, so that's 2 over the square root of 13. I'll do this cosecant next. Cosecant is going to be the reciprocal of this, so that would be square root of 13 over 2. And I know, let me go back and rationalize this denominator here. I'll have to multiply by square root of 13 over square root of 13. So now I would have 2 square root of 13 over 13 for my fractional answer with a rational denominator for sine theta. Cosine. Cosine is adjacent over hypotenuse, so -3 over the square root of 13. And then when we rationalize, when we multiply by square root of 13 over square root of 13, we end up at -3 square root of 13 over 13. Secant would be the reciprocal, so the square root of 13 over -3. Tangent, that's TOA, that's opposite over adjacent, so that would be 2 over negative 3. And cotangent, the reciprocal, negative 3 over 2. And we're in quadrant 2 where only sine would be positive, right? Simply sine and its reciprocal cosecant. Those are the only two fractional values here that are positive. The others are negative, as they should be. Okay, it also asks for the quadrant. Well, we said quadrant 2, so let me answer that. I'll just put quadrant 2 here. And find theta to the nearest degree. Okay, so let's say if I take sine of theta is this 2 square root of 13 over 13. So if sine theta equals this, now I'm finding theta. So theta is going to equal the sine inverse of 2 square root of 13 over 13. All right, so we go to the calculator. Sine inverse, that's second sine. And I suppose I'll key it in as a fraction. 2 square root of 13 over 13. To the nearest degree, that would be 34 degrees. So let's say this is approximately, so theta is approximately 34 degrees. But that's our reference angle. So actually I should have referred to this as the reference angle, right? Because our angle is actually in quadrant 2, right? So in quadrant 2, if we have a reference angle of 34 degrees, then our actual angle would be 180 minus 34. (146 degrees). So that's our angle theta. Number 3, we want to find the exact value. All right, so exact value. The cosine of 135 degrees. Well, 135 degree angle is not acute, so we express cosine of 135 in terms of its reference angle, positive acute angle. Now, 135 degree angle, if we were to draw it, it would terminate in quadrant 2. And in quadrant 2, using all students take chemistry, is cosine positive or negative? Well, it's negative. So cosine of 135 is going to equal negative cosine of, what's the reference angle? 180 minus 135 is 45. So our reference angle is 45 degrees. So negative cosine 45 degrees. And let's see, I'm going to use the trig table, and I think I'll draw it right here. So hopefully you can see it and refer to it as I do the other problems. This is sine, cosine, 36, nope, let me get the 45 in there. 30, 45, 60. 1, 2, 3, 3, 2, 1, all over 2. All right, so negative cosine 45, cosine of 45 is going to be the square root of 2 over 2. So this would equal negative square root of 2 over 2. This is our exact value. Tangent of 330 degrees. 330 degrees is not an acute angle. So we want to express this in terms of its reference angle. A 330 degree angle would terminate in quadrant 4. Reference angle would be 360 minus 330, which is 30 degrees. And in quadrant 4, tangent is negative, so this would be equivalent to negative tan 30. Tangent of 30 degrees, if I'm looking at 30 degrees, it's going to be sine over cosine. So the square root of 1 over 2 all over the square root of 3 over 2. square root of 1 over 2, all over square root of 3 over 2. These denominators of 2 would just divide out. This is equal to the square root of 1, which is 1, over the square root of 3. Rationalize that denominator, so we multiply by square root of 3 over 3, and we get square root of 3 over 3. Okay, let's not forget it's negative tan 30, so let's bring down our negative. So this is negative square root of 3 over 3 is our exact value. And I didn't show that rationalizing by multiplying by square root of 3 over square root of 3. I'll try to fit it in there. Next, cosine of 240 degrees. Again, a 240 degree angle, I'm sorry, I said cosine and it's cosecant. A 240 degree angle is not acute. So we want to express this in terms of its reference angle. So it would be cosecant of 240 degrees is 180 plus 60 more. So this would have a reference angle of 60 degrees. So this would be equivalent to cosecant of 60 degrees. Cosecant's the reciprocal of sine. And in quadrant 3, right, we're in quadrant 3 here. All students take chemistry. Sine is negative, so this is equivalent to negative cosecant 60. Now, reciprocal of sine, if sine of 60 is square root of 3 over 2, then I just want the reciprocal, so I want 2 over square root of 3. So this would equal negative 2 over square root of 3. And rationalize the denominator by multiplying by the square root of 3 over square root of 3. And this is negative 2 square root of 3 over 3. And this is our exact value. D, the sine of negative 150 degrees. Negative 150. I could add 360 to get a coterminal angle. So if I did that, if I add 360, that's 210. So this would be equal to the sine of 210, which is not an acute angle, so I'll have to express it in terms of its reference angle. All right. 210 degree angle would end up in quadrant 3, and its reference angle would be 30 degrees. And in quadrant 3, sine is negative, so this would equal negative sine 30 degrees. Look at the trick table. Sine of 30 degrees would be square root of 1 over 2. Square root of 1 is 1, so that'd be 1 over 2, negative. So negative 1/2. All right. If I didn't add the 360 to get a coterminal angle, the other thing I could have done was to actually draw the negative 150. That would mean clockwise 150 would end up in quadrant, sorry about that, there we go, would end up in quadrant quadrant 3. The reference angle would be this 30 degree angle here. So it would be equivalent to negative sine 30. We'll still come up with the same value, of course. Just a quick check on the calculator. All right, if I key in sine of negative 150, I do get negative 0.5, or negative 1/2. Okay, next, number 4, find the value of the x to the nearest minute. Okay, sine of x is equal to this decimal. It's a positive value. To the nearest minute, well, theta, or sorry, this is x. X is going to equal the sine inverse of this decimal value. So we go to the calculator, key in sine inverse of second sine, 0.072. All right. This is the decimal degrees. We need to the nearest minute. So we will press second angle, second, and then the angle, and DMS is number 4. So 4 degrees, 7 minutes, 43.927 seconds. All right, we look at the seconds. Let me write this down if I can. Okay, so this is 4 degrees, 7 minutes, 43.927 seconds. So we look at the seconds. If the seconds are 30 or more, we round up to the next minute. So this would be 4 degrees, 8 minutes. 4 degrees, 8 minutes. Next, number 5, find 2 values of theta. Theta greater than 0, less than 360, if cosine of theta equals negative 0.4732. We want 2 values of theta here. Okay, well first, this decimal value is negative. In what quadrants is cosine negative? Cosine is negative in quadrant 2 and quadrant 3. So we'll have one angle from quadrant 2 and our second angle from quadrant 3. To go to the calculator, we're going to get the reference angle, the acute angle, we will key in the cosine inverse of 0.4732. So second cos, and then 0.4732. Rounding to the nearest degree, that would be 62 degrees, but this is our reference angle. So our reference angle is 62 degrees. If we have a reference angle in quadrant 2 of 62 degrees, what's the actual angle that shares its terminal side? It would be 180 minus 62, which is, I believe, 118. Yep, 118. And then quadrant 3, a reference angle of 62. Share the same terminal side as 180 plus 62, which is 242. And again, if I check, if I just key in the cosine of theta, the cosine of 242, one of my angles here, to get a value close to our decimal. Yeah, negative 0.46947. It's close to negative 0.4732. Okay, and number 6. Evaluate cosecant of 55 degrees, 15 minutes, 32 seconds, round to 4 decimal places. All right, cosecant's reciprocal of sine, so we'll key into the calculator 1 over sine 55 degrees, 15 minutes, 32 seconds. So 1 over sine 55 degrees, we have to do second apps, number 1, 15 minutes, second apps, and 32 seconds. 32, and then, where is it again? Now the lights went out on me, so it's a little difficult for me to see. Okay, it's alpha plus. Take that off, sorry. Alpha plus gives us our seconds. Round to 4 decimal places, 1.2169. 0.2169. And that concludes our video. Thank you.